right, so we are going to move on to our greatest common factor. And I need to get rid of this. So our greatest common factor. A number is composed of other numbers. So in our first blank, we're putting the word composed. A number is composed of other numbers called factors. For example, 2 times 3 equals 6. The numbers 2 and 3 are factors of the number 6. When a set of numbers has the same factor, it is called a common factor. The greatest common factor, which we talked about in our vocabulary video, is the largest factor that a set of numbers have in common. So just a quick review. Now there's a couple of different methods we're going to work on to find the greatest common factor. The first is the factor tree. So if you remember the factor tree, you break apart the number and you think, okay, what times what can give me 15? Well, 3 times 5. And then you think, other than 1, can I multiply anything together to get 3? No, I cannot. And could I multiply anything together to get 5? Other than 1 and 5, I cannot, so I leave it alone. Now 60 is a different number, so let's go ahead and start with that. With 60, I see that it ends in a 0, so I know 5 can go in there. And let's see, 5 times 12 gives me 60. I cannot break down 5 anymore, but I can break down 12. 12 breaks down into 3 times 4. And then 4 can break down into 2 times 2. I left 3 alone because nothing, I cannot multiply anything other than 3 times 1 to give me 3. It is prime. So I'm breaking these down into my prime factors. All right, then what I need to do first is I see what factors match between 15 and 60. I have a 3 here and a 3 here. So these two match. And since they match, I'm going to go ahead and put them in the center because I'm going to put the factors for 15 on this side and the factors for 60 on this side. So 3 matches between them, so it goes in the middle. And then I see there's a 5 here and a 5 here. So these match, and I'm going to put that one in the middle. Now, what about these two? These two do not have a match over with 15, so they stay over here. And I need to also think, why did I not use 12 and 4? And the reason is because I've already factored these two down into 3 times 2 times 2. If you look, 3 times 2 times 2 equals 12. Okay, so these numbers that are in the center, I multiply them and they will give me my greatest common factor. My greatest common factor between 15 and 60 is 15. Now we're going to talk about the ladder method, which is my favorite method. It's upside down division to find the greatest common factors. We look at 20 and 16, and we're going to use this upside down division and help us find the prime factorizations. And I have to think, what do I know that can go into 20 and 16? Well, they both are even, so I know that 2 can go into 20 and 16. And then I say 20 divided by 2 is 10, so I'm going to put that right here. And 16 divided by 2 is 8, and that goes right here. And then I draw my line again. Now, is there anything that can go into 10 and 8? Yes, 2 again. I put my 2. 10 divided by 2 is 5. 8 divided by 2 is 4. I look at 5 and 4. Is there anything that can go into 5 and 4? No, so I'm completely finished. These numbers that are on the side are my factors that these two numbers have in common. So I will multiply them, and that's going to give me my greatest common factor. 2 times 2 gives me 4. So the greatest common factor between 20 and 16 is 4. Let's try that one more time between 24 and 40. I know that 2 can go into 24 and 40. And 24 divided by 2 is 12, and 40 divided by 2 is 20. Can anything go into 12 and 20? Yes, 2 again. Draw my line, put my 2. 12 divided by 2 is 6. 20 divided by 2 is 10. Can anything go into 6 and 10? Yes, 2. So 6 divided by 2 is 3. 10 divided by 2 is 5. Can anything go into 3 and 5? No, it cannot. I'm left with 2 times 2 times 2 to get my greatest common factor, which equals 8. And I just like that one because then I don't have to make the factor tree and then try to find the factors that they have in common. It's just all right there on the side of the ladder. Now we're going to solve a couple of problems on our own. First, we're going to find the greatest common factor of 24 and 6. And for this one, I will use the factor tree again. So we have 24. Move that down. 24. So let's factor that out. What can go into 24? Well, 2 times 12. 2 is prime, so then I'll say 2 times 6. And then I'll say 2 times 3. And that's as far as I can factor it down. Now I have 6. And the only way I can factor that one is 2 times 3. Now what I like to do is just go with a highlighter and I say, okay, there's a 2 here. Oh, here's a 2 here. And then there's a 3 here, and here's a 3. But there's no other numbers. So for my greatest common factor, I say 2 times 3, which gives me 6. The final one, we're going to use our ladder method. We have 18, 24, and 60. I think what can go into 18, 24, and 60? Well, I know 2 can. 18 divided by 2 is 9. 24 divided by 2 is 12. 60 divided by 2 is 30. Now, is there anything that can go into 9, 12, and 30? Yes, 3. 3 can. 9 divided by 3 is 3. 12 divided by 3 is 4. 30 divided by 3 is 10. Now, can anything go into 3, 40, and 10? No, it cannot. So I have my 2 factors right here. So my greatest common factor equals 2 times 3, which equals 6 again. So you can use whatever way you choose on your practice page. You are only going to be working on the greatest common factor side. Do not try to do the least common multiple side until we have done the video.